Dalton's atomic theory is based on numerous observations, and the law of conservation of mass is a statement that summarizes a lot of those observations. The law of conservation of mass, also known as the law of conservation of matter, was formulated by Antoine Lavoisier, who is also referred to as the father of modern chemistry. And basically, that's law of conservation of mass. That statement says that matter is neither created nor destroyed. Classic experiment that Lavoisier did in 1780 involved hydrogen and oxygen uh, reacting in an enclosed chamber, and the reaction is triggered by an electrical spark to produce water. In that chamber, the total mass of that chamber was measured before and after the change occurred, and the total mass was found to be the same. Dalton's explanation for that is pretty simple. Atoms are indestructible. If atoms are neither created nor destroyed, then as long as no atoms leave or enter your system, then the total mass of your system is going to be constant. Okay? Of course, the modern view about the law of conservation of mass is that matter can in fact be thought of as a form of energy. So you could say matter and energy are interconvertible, and Einstein's famous equation E equals mc squared summarizes that relationship between matter and energy. Okay, so if I could actually lose matter and transform it into energy, and the amount of energy I can get would be given by the mass times the square of the speed of light. C here is the speed of light. But changes in mass are typically negligible compared to our ability to measure mass. Okay, so unless huge energy changes are involved, the law of conservation of mass is still pretty much valid. So as far as most of the things we deal with in chemistry, uh, we're just going to assume, we're just going to take the law of conservation of mass as valid. Okay, things would be different if you're looking at processes where the nucleus would split, for example, or if two nuclei were to join together. So nuclear processes, generally those are the kinds that involve huge energy changes, and there the law of conservation of mass is not valid.